expressions, when we call them variable expressions, okay, a variable expression is a mathematical expression, okay, first of all, but mainly a variable expression is an expression with a variable and some type of mathematical operation done to it. Okay. Mathematical operations, once again, would be adding, subtracting, multiplying, or dividing. Okay. So, an example of a variable expression would be this: x plus 4. Y minus 6. Okay. It also could be w minus z. Okay, that's a variable expression. 3x. Okay, 5 over y, or 5 divided by y. Okay, those are all examples of variable expressions. Now, when we see a number right next to a variable, or two variables right next to each other, it means to multiply. Okay, so this right here means to multiply. This is division. Okay, so when we have these, it gives us a little bit of, those are the only two that you're probably obviously not familiar with. Okay, but like I said a while ago, you could have this, xy. Okay, well, xy means to multiply whatever x is times whatever y is. Okay, sometimes we'll know those values, sometimes we won't. Okay, so those are all expressions. Okay, an equation the book gets into a little bit more complicated definition about it's in mathematical open sentence, blah, blah, blah. Bottom line is, an equation, for our purposes, is a variable expression with an equal sign. Okay, so I could take all of those expressions that I listed up above, x plus 4 equal 20. That makes it an equation because I put equals 20. Okay, you could have y minus 6 equal 32. Okay, and the only difference between the two is it has an equal sign. Obviously, we could do this. You could say 4 is equal to w minus z. Okay, so that's what makes it an equation, is that it has an equal sign. There's something that it's equal to that we can find out what x is equal to. Okay, you've seen these. Okay, when, in the sections, different sections throughout the first 6 chapters where it says use mental math to solve. Okay, or find the value of the variable. You've had ones like this. 4x equal 20, and it tells you to use mental math to figure out what the value of x is. Well, what would the value of x be there? 5, because 4 times 5 would be 20. So you've had all this stuff. Now we're just basically taking it a little step further, and it's obviously, in this chapter, it's going to get a little bit more complicated than what you're used to seeing. Okay? Today, what we're going to talk about is taking a word sentence and writing an expression or an equation for that word sentence. Okay? For example, if I had 4 more than a number. Okay, 4 more than a number. Now, the key words there, more than. Okay, you'll see, I think it's on page 323, or no, actually, excuse me, 317. On page 317, there is a table of common words to express certain mathematical operations. Okay, if you look at that table, the words more than are under what operation? Addition. Okay, so the words more than mean to add. So in this problem then, 4 more than a number, how am I going to write that? First of all, do you think it's going to be an expression or an equation? An expression, because the equal sign, the word equal, and the word is means the equal sign. Okay? The word equal and the word is means the equal sign. Is there either one of those words in this expression or in this sentence? No. Okay? So I guess then we're dealing with the variable expression, which we are. Okay? So basically then all I have to do is just translate the words. The word for means 4. The words more than mean addition. A number means x. So 4 plus x. And that would be your answer. That's your variable expression for that specific sentence. Now, you got to be careful when you read the directions and make sure that you use the right variable. Sometimes in the directions they will tell you which variable to use. Sometimes in the problem or the word sentence they will tell you what variable to use. If they don't give you a variable, then it doesn't matter. Okay, you can use whatever variable you would like to use. For example, everybody look at page 319 at number 13. Okay. It says there to use y to represent the number. Okay, so you would have to use y or you'll get it wrong. Okay. In 7 through 12, it says let x represent the number. Okay, so you'll have to use x or you'll get it wrong. Okay, so there are times that it's going to tell you which one to use. There are times that they may give you the option to let you use whatever you want to use. Okay, so let's look at some of these examples. I just did number 2. Number 2 says 4 more than a number, okay, and they want you to match it with the expression. Okay, so which expression on the right would 4 more than a number be? Obviously, it's right there, and so what letter would that be? B, okay, so fairly simplistic, not real hard. Number 3 says the quotient of a number and 4. The quotient of a number and 4. What does the word quotient mean? Division. So the quotient of a number and 4. Okay, the quotient means division. Okay, so that means division. Well, obviously, we're not going to have a division sign and then 2 numbers after it and nothing in front of it. Okay, so it says the quotient of a number and 4. We're just going to go in order. How do we write a number? X. In this particular case, I think that's what they want you to write, x. And so that gives me x, then my division sign, then 4. Okay, and that would be your answer, but what is the letter that corresponds to that expression? C. So the answer there would be C. Okay. So somewhat simplistic, not necessarily real hard, but we'll get into some harder ones here. Let's move down. Let's look at number 7. Number 7 says a number added to -7. Now, obviously, as you see right here, we're going to have negatives and positives in these problems. Okay, a number added to -7. All right. So, what is the words? The key term there is obviously added. Okay, so does that mean I'm going to subtract? Divide? Multiply? No. It means we're going to add. The direction tell us what variable to use. X. So, a number, which would be x, added, which would be plus -7. Okay, now, remember, because of the commutative property of addition, this problem is exactly the same. Okay, those two answers would be exactly the same. They're equivalent, so they're obviously this is correct. Okay, I don't care which way you put it. I tend to go in order just like it is in the sentence, provided that's the correct way to do it. Okay, that leads me to my next point. Let's look at this one. I can't find one right off the bat, but we need to look at this. A number less than 22. A number less than 22. All right, what's the words less than mean? Subtract. If I have less than somebody else, then something's obviously subtracted from mine. Okay? Now, the words less than are the ones that are different. Okay? The words less than are different because of this. Zach, I want you to tell me what is the number that's 4 less than 22? What is the actual number? 18. What did you do in your head? 22 minus 4. Okay? By the way this sentence is, you would be tempted to do this. Okay? That would be wrong. Okay? This is wrong. When you see the words less than, you must reverse the order of the numbers or variables. Okay, so this is what this should read is 22 minus x. Okay, so that is the correct answer when you use the words less than. Now, it is only with the words less than that we do that. If they would have said a number decreased by 22, then it would be x minus 22, because decreased means to subtract, and we're going to subtract it by 22. Okay? But if I said that Emma has $30, okay, and Zach has 5 less than, okay, you're not going to go 5 minus 30. You're going to go 30 minus 5 to find out how much Zach has, okay? And so that's with the words less than. The other thing is there is no commutative property of subtraction. In other words, 22 minus 4 is not the same thing as 4 minus 22. Okay? 22 minus 4 is 18. 4 minus 22 is negative 18. Okay, so there's not a commutative property, so I can't flip the numbers around when I'm talking about subtraction. I can only do that when I'm talking about addition. Okay? Now, I want you to do number 9 and number 11 in your notes. Do number 9 and do number 11. When you have the answer to those, raise your hand. Only one person has it? 2 people? Okay, well, that's what I meant when I said when you have the answers, raise your hand. Not prop it up on the desk. Raise your hand. Okay, Emma, what'd you get for number 9? Let me look at it. Let me look how you wrote it. No, that's not it. Nick? Put X over 3?
Yeah, I don't know.
No, that's, yeah, it's sort of right. That, you're hitting on both of them, but what's the word of mean? Look at the table. It means to multiply. Yeah. The word of, if you look at your table, means to multiply. So I need to multiply 1/3 times something. Okay? And in this case, the direction said I have to use X, so it's just 1/3 X. We don't put this, do not do this. Don't do that. Okay? When a number's next to a variable, that a number is 1/3 a number. Yes, it is. It's a fraction, but it's still a number. So when you have a number next to a variable, it means to multiply. We don't want to put the multiplication symbol, the X, because obviously if I did that here, it would be confusing. 1/3 XX. Okay? We don't want to put the dot. Don't put parentheses. 1/3 X is your answer. Okay, now let's look at the other one. Negative 50 decreased by a number. Drew, what'd you get for that one? Nope. Yes, sir? Negative 50 minus X, yes. Negative 50 minus X. Remember, I just said a while ago, the only time we flip the numbers is on the words what? Less than. Does this say less than? No, it says decrease by. Okay? So you do not flip it when it says decrease by. You only reverse the order of the numbers when you have the words less than in the sentence. So it's just go in order. Negative 50 decreased by means subtraction, a number, x. Okay? And that would be your answer for that one. Now, let's look at equations. Let's look at number 13. Number 13 says the sum of a number and negative 9 equals 24. The directions here tell you to write a equation. It says write the verbal sentence as an equation. Let y represent the number. Okay? So what does the word sum mean? S-U-M, not S-O-M-E, obviously. Joshua, adding. Sum means to add. So I'm going to add two numbers. What two numbers am I adding here? Y and negative 9. So y plus negative 9, there's your equals 24. So the two key things in here is the word sum and the word equals. Okay, it tells you that it's an addition problem. The word sum, S-U-M, tells you it's an addition problem. And the word equal obviously means the equal sign. I don't really like when they use the word equal for the equal sign because most of the books from this point on are not going to use that for the equal sign. They're going to use the word is. Okay? All right, let's look at number 14. No, that'll come later this week. The product of a number and negative 5 is 10. The product of a number and negative 5 is 10. Okay? So once again, what's the word product mean? Multiply. Multiplication. So the product of a number and negative 5. How do I write that? How do I write the product of a number and negative 5? Negative what? Yes. Negative 5x equal 10. Now, it is not okay for you to write this. Okay, that is not acceptable. Do not do it that way. X times negative 5 with parentheses. When you're multiplying, okay, when multiplying a number and a variable, the number must go in front of the variable. Without the multiplication sign. Okay? So when those of you that are not writing that statement down, do that on the homework tomorrow, you're going to get it wrong. But it's the same thing. I don't care. You've been given instructions of what to do. You must do it that way. Quite simply because of what we're going to get into in Section 2 of Chapter 7. Section 2 of Chapter 7, we'll get into some simplifying terms and all that. And so you need to be in the habit of writing the number in front of the variable and not behind the variable when you're multiplying. Plus, the simple fact is, if we did this, if we actually wrote it without the multiplication sign in it, then it looks like what? It's x minus 5. Okay, another reason why we don't write it like that. Okay, but the number always goes in front of the variable when you're multiplying, every single time. Okay, I want you to do number 15 and 16 on your own. Hopefully we'll have better luck with these than we did the first two. See what? Emma.
13 equals 5 minus 1.
Yes. 13 equals 5 minus y. That one's pretty straightforward because it uses the word minus, so we don't reverse the order. Okay, but minus does mean to subtract. Okay, obviously the directions told us to use y, so we have to use y. Okay, in 13 they got you with both words, is equal. Okay, so yeah, that's pretty much the equal sign. Okay, now, number 16 says 1/4 of the difference of 6 and a number is 200. Okay, this one's a little harder. Think so? Okay, if you don't, you get to write 1,000 times I was wrong. Just joking. All right, what'd you get?
6 minus x divided by 1/4.
No. No, y'all gotta get. I mean, it is division, okay? It is division, but you don't. I'll show you how you can write it here in a second as a division problem. Okay, what's the word of mean? 1/4 of. So, Owen, what did you get?
1/4 times 6 minus y equals 200.
Close, but no. He's on the right track. He's just missing one point that y'all don't know to put in there yet. Okay, it is 1/4 6 minus y equal 200. Here's the key. It says of the difference. Difference means the answer to a subtraction problem. Okay? So I have to do that. I have to put the parentheses around it, so I do the 6 minus y. They want 1/4 after we subtract. Okay? If you leave it like this, that means 1/4 times 6. And then subtract that from y. Is that what you had? You had the parentheses. Well, then you would say it. If you're saying it with parentheses, you would say, if you're saying the answer, you know, I call on Nick to call out his answer, it would be 1/4 parentheses 6 minus y, close parentheses, equal 200. Okay, that's how you would do your, if you have parentheses listed, that's how you would do it. This one over here on the right is wrong. The one on the left is correct. Okay? Just like if they said 1/3 of the sum of whatever. Okay? Then they want you to take 1/3 of the two numbers added together, add them together before you multiply. Okay? Now, the way that y'all are trying to do this 1/4 and make it a division, it is division, okay? But it would have to look like this. That's how you would write it as a division problem.
Please come to the office.
Who? Oh. That's how you would do it as a division problem. Okay? If you were taking 1/4 of 6 minus y. Okay? So that would be a division problem. That's how you could show it as a division problem the other way. Okay? you can't do it like y'all have been saying. Y'all have been saying this. For example, you said Zach said this. Okay, 6 minus y divided by 1/4. That's not the same thing. Okay, because we have to do the reciprocal, so that would actually be 6 minus y times 4. Because it has a fraction in it, we have to do the reciprocal of the fraction and multiply. Okay, so that's why that is not correct as well. Okay, so you need to pay attention to the wording. There's a couple of those that need parentheses in there. Okay, all right, so we're going to do this. You're going to do 7.1, 2 through 17, and 26 through 39. 7.1, 2 through 17, and 26 through 39. Okay? You may go.